Okay, the previous video we looked at this queuing calculator that gives you some nice easy formulas. Given these two, we can calculate all these, including these performance metrics in this table. But the problem with queuing theory is that when the problems get more complicated, then the queuing formulas get really hard, and in fact, to some extent, it's almost impossible to come up with the formula. And so what I want to do is show you a different way to get to these numbers using something called simulation. And we'll start doing a very simple problem, but hopefully you'll see the power and the benefit of this. And we're going to do it all in Excel. This is an Excel example. There's nothing new in Excel. And you can see I've got multiple worksheets down at the bottom, so we're going to jump into this single server. And so we're going to look at it as a single server system. It's the exact same example that we just did. We have one line, one server. It's called an MM1 because the M stands for Markovian or Markov chains. All that means is that the time between arrivals and the service times are both exponential. That's all that means. So we have people arriving to a system, wait in one line, first in, first out. They get processed and they leave the system. So let's look at this. I've got a customer showing up, and look what I've done is I'm generating a random number in Excel. Now, why am I generating that random number? Because what I do is that once I generate that random number, look what I do is I calculate the time for the next arrival. And it's based on this arrival rate, and this formula in Excel, using the natural log, all I've done is take the formula that is in the PowerPoint and do some manipulations and convert this to where it's running in seconds. But other than that, that formula generates a random time between arrival that is based on people showing up every 15 people per minute, or every four, in this case, what would that be? 4 seconds. So I went from minutes, hours now to seconds and minutes. So that's a random number. And I'm going to hit the function key 9. And you can see they're random, so the numbers change. So when the number's high, it generates a long time between arrival. Remember what this is, every 15 per minute. That means the average time between arrivals every 4 seconds. So when the number's kind of in the middle, I get something close to the middle of that. When the random number, let's get a random number there's a really small one. So the time between arrivals, basically instant. That means that someone shows up, and then right after that, I could show some decimals. Let me show some decimals. But when we have a small number, the time between arrivals is actually less than a second. That basically means someone shows up and then right behind them shows up. I'm sure you've seen that in fast food restaurants. Someone shows up and right behind them someone shows up. They're not related. It's just the way customers behave. But when I pull a high number, there's a high number, the time between arrival gets pretty high. And all that means is that we may go a while before someone shows up. So if this person always shows up the beginning of the simulation, the next person shows up the time between arrival from the next one. So you can see this is the actual times that the customers are showing up. The first one shows up at the beginning, the next one shows up 7 seconds later, and then the time between arrival of the third one is really short because I pulled a low random number, so they basically show up right after that. So now I'm starting to put on a calendar these events, these customers showing up. Well, now let's get to the service side. The first person always shows up, they never have to wait. They show up at 0, they get to begin at service. But the service time is also random. I'm using the same formula, except rather than referencing the arrival rate, I'm referencing the service rate. So I pull a service time based on serving people 20 per minute. So this is when they show up, and so they begin at 0. It takes 3 seconds to serve them, so at the end of 3 seconds they're finished. But that's not always the case. We can see for the second person, look at the second person, they show up 7 seconds into the model where the first one's already done because they're done at 3. So they can start at 7 because they showed up and there's no one in the system. But look at customer 3. Customer 3 also shows up at 7 seconds into the model. They're ready to begin service when they show up. They want to show up at 7 seconds, but they don't begin at 7. They have to wait until 9. Why do they have to wait till 9? Because the customer in front of them ends at 9. So now they've actually started, there's a queuing time. There's a queue that's occurred. There's a waiting time that's occurred. So this is when queues occur. So if you look at the formula for this, the time that a customer can begin service is a function of when they show up as well as the previous customer leaves the system. That's how you can model queuing systems in Excel. Once you have those, you just copy these formulas down, and then over here I can calculate the total time in system. That's what WS is. It's the time in the system. It's the time that they end for a customer when they ended and arrival. These are a little bit more complicated. We'll talk about those in class, but this is the time and the number of people in the system, and this is the time in the queue. Once you have these, I'm going to go to the output. Just like before, this is the utilization that comes from the queuing formula, 75%. That's what we had before, 75%. But now that I've got a simulation, I can look at the simulation output. And you can see it's not exactly the same, but it's close. Sometimes it's less, sometimes it's more. That's just how it goes. And then I can also track the number of my customers in the queue over time. So you can see that my queue really spiked to over 17 one time right then. Now that's not going to happen very often, but it can happen. Back to the calculator, the average queue size was 2.25. Well, I can calculate that also, and you can see sometimes it's lower than that. Sometimes it'll be a little bit higher. Oh, that one got really big. But you can see when you start using simulation, you're not going to get the closed form equations every time. Okay, that's how we can model a system that is a single server system using a calculator. This is how we can now model it using simulation. Thanks.